some what? We look at the topic of traffic flow theory, okay, which is the set of equations which are used for analysis of traffic flow. We look at some graphs, we drive some equations, and so on and so forth. Okay, and I left you with this question, okay, in which you have to repeat the same steps which we have done in the previous example. Okay, so what are they asking for here? They are asking for free flow speed, which is the maximum speed when density becomes 0. Okay, and they are asking for jam density, which is the maximum density when speed becomes 0. And they are also asking for capacity, okay, which is what? Maximum? No, this is maximum density.
Flow rate.
Maximum flow rate. Okay, this is maximum flow rate. Okay, nothing becomes 0 here. Nothing becomes 0. If you make something 0, I will also make something 0. I will not like it. Okay, okay, capacity, nothing becomes 0. Okay. Moving on. So I left it to you. If anybody tried it, they want to show it to me, they are more than welcome. If they didn't try it, be happy. Okay? Don't worry, be happy. There? Okay. Then I showed you this. We have already discussed interrupted flow facilities. And the reason for discussing it over here after traffic flow theory was the application of the equations. Those equations which we have seen, do they apply to the intersection or not? They don't apply to the intersection. Because in the intersection, the flow does not stop because of traffic jam only. It can stop because of a red signal. Maybe there is only one vehicle. You still have to stop, right? Okay? So, this was the reason of discussing it over here. Okay. Then we have these three things. The rest of the discussion will be, today we will discuss these three things in more details. We have demand, volume and capacity. Okay. Out of these three, we already discussed two of them. Which two? Capacity and volume. Okay. Volume can be what? Hourly or daily. Okay. And now out of these three things, capacity is what? Maximum. You already said it. Maximum flow rate. Okay. And what is demand? Then let me define the demand. Demand is number of people or vehicles which want to pass through the highway. Okay. Demand is what you want, right? Demand is, I am demanding this, right? Okay. So demand is what you want. Okay. And you don't get always what you want. Right or not? Okay. You don't always get what you want. And then you repeat the course, right? Right or not? People are busy. You may be writing it. You repeat the course. Did you write it? Then you repeat the course. Did you write it? Everybody becomes a genius at this point. Okay. What is it? Yeah. Out of these three, one is a constant. Which one? Demand, capacity, volume. Which one is a constant? It's a constant number. It doesn't change. You cannot say it is 11 a.m. this much and 12 a.m. is this much. Capacity is a constant. Capacity, how can capacity change? How can capacity change? Okay. We have seen the lift, right? When you enter the lift, they show the capacity, right? 20 people. Does it change? Okay, now the capacity is 20. In the evening it will become 18. Does it happen? No. It always remains the same. But the number of people in the lift can change. That is volume. Okay. Or the number of people who are waiting for the lift can also change. That is demand. Okay. Now, which one affects the other? Demand affects volume, or volume affects demand?
Demand affects the volume.
Demand affects volume, right? People. Okay? People decide how many want to travel, right? Okay? Demand is the people. Huh? Choice of the people. Okay? So, it can happen that demand goes more than capacity, right? It can happen that demand is more and the capacity is less. Again, going back to the example of the lift. The lift can have the capacity of 5 people and there may be 6 people waiting for it, right? It can happen, right? The demand can be more than capacity. Okay? When demand is more than capacity, you have these options available to you as a driver, if you know it. Okay? If you know demand is more than capacity, maybe you will choose one of these things. Go from a different height if you know about it. If you don't try it. Okay? Well, if something like me, you will waste your time, half an hour, and then come back on the same highway and get stuck again. Okay? So just be stuck, okay, relax. One of my friends told me, he's an old batchmate, we did engineering together. Yes, even at my time it was engineering. So we did it together and he was telling me once he was stuck in the traffic jam, he was enjoying himself. I said, dude, why? Okay, but there are people like this. Okay. So the point was you can go from another highway, right? Instead of that highway, choose another one. There is one of the possible options. So if you choose that option, you are not in the traffic jam, right? You are not there now. Okay? You wanted to, but you are not. You wanted to go from there, but there is a traffic jam. You went from somewhere else. Clear? Or travel at another time. Okay? I sent a message to the doctor. I want to go in the other section because I have flash. Right? You know that, right? Trying to give you examples which you understand. What happened? Okay. And then you can travel to a different destination. Today I am not in the mood to go to the class. I am feeling very tired. I'll go to the gym. I'll go to the gym, put half an hour there, get more tired and go to sleep, right? Who wants to go to the class and get bored? Right or not? Why? Okay. And the last one is our favorite, right? Staying home. Best place to be, right? In the evening, go to the clinic, get an excuse. What else do you want? Okay? Clear? Clear?
But still not an acceptable excuse, doctor.
Sorry?
So let's say if I didn't come to your class,
Yeah.
I came tomorrow, you asked me why didn't you come? I have to stay home. It wouldn't be accepted.
Yeah. So you go to the clinic, right? You go to the clinic and get the excuse, right? You let the doctor say for you. You are not fit to go to the class. If he knows you better, he would know that he is never fit to go to the class. They give you the excuse for the whole semester. Or for the whole 4 days. Anyways. The point is, any driver who takes one of these options, he is not on the road which has a traffic jam, right? Okay. Is he part of the demand? Yes. He is part of the demand, right? He wanted to. Okay. But then he changed something in his plan. Okay. So the actual volume which you see on the road is not the actual demand. There are some people who will be going from different highways, or at a different time, or maybe not, or cancelling the trip because of a traffic jam. So the actual demand is volume you see on the road plus something more. Clear? Okay. What else I was trying to mention here? Yeah, and this is what happens on the highways. When they expand the highway, they make another lane or they put a new bridge. Okay, and the expectation is okay. Now we are safe for maybe next 20 years. Okay, but then you come after 1 year and you see the same situation. giving the extra lane and the bridge and everything. What's the reason? These people. Okay? When you were looking at the highway, you were not looking at these people. Because some of them were on different highway. Some of them were staying home. Some of them were coming at a different time. But when you expanded the highway, these people thought, no, yeah, it's party time now. Let us all go at the same time. I don't have to go from another place or cancel that trip and so on. So this is the extra demand which comes on the highway. Okay, and then you see the effect. Okay, when demand goes more than capacity, we have to measure the effect. We cannot just leave it. We have to measure the effect of this exceeding of demand from the capacity. When the demand goes more than capacity, we have to measure the effect. And the effect is measured in 3 terms. The effect of demand going over capacity is measured in 3 terms. Okay? First, when demand goes more than capacity, how long will be the queue? Okay? Demand goes above capacity, how long the traffic jam will become? Clear? Okay. Second point, how much time it needs to clear the queue now? Okay. So how long is the queue? And then how much time the queue will need to clear? Until the queue is cleared, you have traffic jam, right? Okay. Until there is a queue, the traffic jam is there, right? You have a line of vehicles. There is a traffic jam, right? Okay. So after how much time this traffic jam will be gone? You want to know that, right? Okay. Clear? And the third thing is, because of this traffic jam, how much delay is caused to the drivers? So I have a problem, then the traffic jam. Because of this traffic jam, the drivers will have how much extra time? The drivers have to spend how much extra time? The delay. Clear? Okay. So how long will be the queue? Okay. How much time you need in the traffic jam, the queue to clear? Okay. And because of this, how much delay it is causing to the drivers? 3 things. Clear now? Okay. We will try to understand the calculation from this example. It is just an example. The numbers can change, the graph can change. Focus on the idea. Okay. Time on the x-axis, demand and capacity on the y-axis. And everything is per minute, because the time is minutes. Okay, clear? Okay. Okay, so now you see 2 lines here, right? One of them is for demand, the other one is for capacity. Okay, you see a straight line and then you see a changing line, right? Which one of them is demand, which one of them is capacity? Straight line is the capacity, because we can set capacity is constant. It doesn't change. Okay? Clear? So this is capacity and this one, demand can go up and down, right? Demand can go up and down. Okay. First 30 minutes, this is 30 minutes. Okay? Demand is what? More than or less than capacity? Less. Okay. Do I have any problem? Less people want to go and the road can handle more. Okay? So no problem. Like now. The room can have more people, but there are only few of you, right? Clear? No problem, right? All of you are sitting comfortable. You can even sleep as well. No problem. Clear? What happens here now? Demand shoots up. It goes more than capacity, right? Okay. Now we start to have what? Traffic jam, the queue. Okay, the queue will start from here. Okay. This remains more than capacity up to this point. This is total 60 minutes. This continues for how many minutes? How many? 60 minutes. Okay. So for 60 minutes, I have this problem and the queue will keep on growing and growing and growing. Okay. Then after this one, it drops down. Okay, it drops down to less than capacity now. Okay, up till here I was having a queue, right? I was having a queue and a traffic jam, right? What will happen now from here onwards? The queue will be gone?
Yes.
Yes? Okay, let us do, first of all, let us start with some calculations. How much is the queue here? How much is the demand? 120, right? How much is the capacity? 75. Okay. So, how much is the queue? 45, right? 120 minus 75, right? The road can have how much? 75. How many are coming? 120, right? 120 are coming. 75 can go. So the remaining in the queue, right? Okay, so what is the remaining? 120 minus 75, which is 45. Okay. Okay. So right now the queue is 45. Here the queue is 45. Okay. But this is the first minute. In the first minute the queue is 45. Does it end here? No. It continues for the next 60 minutes, right? So 45 into 60. Clear or not? Sure. Is it clear? Everybody? Huh? Should I move on? So, every minute, this many vehicles in the queue. There's 120 minus 75, which is 45. So, every minute, 45 in the queue. Total, how many vehicles? 45 into 60. Okay? Which is equal to okay, 45 into 60 is 2700. Okay. Okay. Now I'm at this point, right? I'm at this point. Now at this point the demand goes down, right? At this point the demand goes down. Now tell me, up to this point I have 2700 vehicles in the queue. Up to this time I have the queue up to how many vehicles? 2700. Will these 2700 vehicles go in a second? They will take some time to move, right? So the queue will not finish at this time. The queue needs more time to clear. Okay? Okay or not? Now, how many vehicles can go from the queue at this time? What is my demand? This is 65. Okay. What is my capacity? 75. How much extra space I have? 10.
So 10 minutes.
Who will use this space? These vehicles. Okay. So I have a space of 10. So every minute 10 from these will be gone. Okay. I have a total of 2700. Every minute 10 from them will be gone. Okay. So how much total time you need? 270 minutes. Clear? Sure. Yes. Clear? Did you send the message? Okay. So now what happened? Up to 30 minutes, no problem. From 30 to 90 minutes, it started from 30, ended at 90. Okay, 60 minutes between them. 30 to 90 is 60, right? Okay. So from here to here, I have a queue of 2700. Okay. From this point onwards, I start to have extra space for 10 vehicles every minute. Okay. So every minute 10 vehicles will leave. In how many minutes all the vehicles will leave? 270. Okay. Total was 2700. Every minute 10 are leaving. So I need 270 minutes. Clear? Any question?
That will cause traffic jam.
Sorry?
That will cause traffic jam.
already started here. It has started from here. It is continuing. It will continue up to there. Until the queue is gone, you have a traffic jam, right? Queue means what? Traffic jam? Queue is traffic jam, right? So until the queue is gone, there is traffic jam. Okay? Okay. So I wanted to know three things. Length of the queue. How much time I need to get rid of the queue. Okay? Now I need the delay. Okay? Now I need to calculate the delay because of this situation to the driver. Clear? Clear? Okay? So, for calculating the delay, I need to do some calculations. Okay? I'll make a table here. 3 columns. Okay. Time 0, 30, 90, do 70. I need how many vehicles are arriving, means coming, and how many vehicles are leaving. Okay, I need to calculate how many vehicles are arriving, how many vehicles are leaving. Okay, clear? At 0, 0, right? We did not start here. Everything starts from time, right? 0 time means nothing. Okay? Then, let me bring it over here. I'll do the calculation over here. Okay, between 0 and 30, at what rate they are coming? 50. Okay, for how many minutes? 30 minutes. Okay. How much will be there? 1,500. Okay. It was 30 per minute, right? Oh, sorry, it was 50 per minute, right? And for 30 minutes. 50 per minute for 30 minutes. Clear? Okay. Next one. Leaving. In this time. All will leave, right? Okay. So this is because there's less in capacity, right? So there's no problem in coming and leaving. So they're leaving at the same rate, right? Okay. Now keep one thing in mind, I am calculating cumulative. This is cumulative. Okay. So I'll add the last number. Okay. This is cumulative. So I'm adding the last number. 1500 added. Okay. Now they are coming at this rate, right? What is this rate? 120. How many minutes? 60 minutes. How much was this? How much is this? Huh? 4,000. I don't know. Maybe
8,700.
8,000. Okay. Now at what rate they are leaving? They are leaving at what rate? How much per minute? This is more than capacity, right? Can they leave at a rate more than capacity? No, right? So they will leave at the rate which is the capacity, 75 per minute. Again, I will add the last number, because this is cumulative, and they are leaving at, okay, how much is this? 6,000. Clear till here? Any problem? Huh? Any problem? No problem, right? Okay. From now, why do I put? Okay, it should not be 270. It should be 360. Why 360? Why not 300? Huh? Why not 2,400? Why not 120? Plus the, huh? Yeah, okay, yes. We need 270 minutes to clear the queue, right? And it starts from where? From 90, right? So 90 plus 270 is 360. Okay, so I'm taking the time where something happened. That's why I went from 0 to 30 and then from 30 to 90. This is not constant interval, right? The interval is not constant. It's 30 here, then 60 here, then 270 here, right? Okay, why? Because at each of these times something changed. Okay, here the demand changed, here the demand again changed, and here the queue is gone. Okay, so I'm selecting the time where something changed. Clear or not? Okay. Okay. How many vehicles? Again, I will take the last number. Okay, I have to find out at what rate they are coming. They are coming at the rate of 65. Now, how many minutes are these? 270. How much is this? Say again, 26,000? 250. Okay. And again, I will take the last number. Plus, now at what rate they are leaving here? 65? 75. Why not 65? The demand is 65. Because of the, yes? Because of the queue. Okay. 10 were leaving from the queue, right? So 65 plus 10. 75. 75 into 270. And this should be equal to what? You already have the number. What number? Same number, right? You should get the same number, right? Okay. Now you can see here in this table there are 3 times at which the numbers are matching, right? Here, here, and the end, right? So numbers are matching means what? There is no queue. Numbers are matching, that means there is no queue, right? At time 0, no queue. Numbers are matching. Time 30, no queue. Numbers are matching. Same thing at the end, right? At time 90, there was a queue. Numbers are not matching. Left, number, no queue means arrival and departure are equal. Okay? Any problem? Anybody has any problem? Is it clear? Clear? Okay. Now you see this graph over here, it is plotted from this table. Time on the x-axis and these numbers on the y-axis. Okay? Okay, number of vehicles on the y-axis. Okay. You see 2 lines over here, right? I have 2 columns, arrival and departure. This is what? Arrival or departure? Up. Departure? One of you could be right? There's only 2 options, right? Okay. This one is what? Yes. This one is what? Arrival. Why? The answer is correct. Okay. Why? Why would I say this one is arrival? The upper one is arrival because there's a queue, so arrival would be higher, right? There's a queue, so arrival is higher, departure is lower. Okay. Second, from here to here it's a straight line, right? The departure is a straight line because, yeah, capacity. From time 90 till the end of the queue, the vehicles were going at capacity, right? So it doesn't change. But the arrival was changing, right? The arrival changed at this point. So you see the change over here. Got it or not? Okay. You see this line is higher and this line has a change as well. Okay. Which is the case for arrival. For departure, this is not the case. Departure is lower or equal. It's never higher. Departure can never be higher, right? Okay. And there is no change. Clear? Okay. Now for calculation of delay, I need the area between the two lines. For calculation of delay, I need the area between these two lines. Okay? Clear? I want to calculate the area between these two lines. Okay. Tell me, what does this look like? Right angle triangle, right? Huh? And what does this look like? Right angle triangle. What is the area of a right angle triangle? Half base into height, right? So I need the difference of these two right angle triangles, right? I need the difference of these two right angle triangles. I need area between the two lines, right? This is a right angle triangle and this is also a right angle triangle. Okay? I need the area between them, right? So this right angle triangle and this right angle triangle. I need the area between them. Got it? Clear? Clear? Huh? Okay. So I'm writing it over here. You said right angle triangle is what? Half base into height. Huh? I'll call it H1 minus half base okay. Base is same, right? For this, for both the triangles, the base is same, right or not? Okay. This triangle and this small triangle, their base is same. Everybody clear? Is it clear? Okay. So can I write this equation as half base H1 minus H2? Because it is same, right? I wanted half B H1 minus half B H2. Okay, so half B is same. Okay, so half B into H1 minus H2. Okay. Sure. Okay, so I need the base. Okay, so this is how much now? This base is how much? No, base. Starts from where?
25.
This. Where did it change? Where did it change? Where did this change? Where did the demand change? 90, right? And where did it start? 30. So what is the base? 60. Okay. So my B is 60. This is half. Okay. Okay. So half base, which is 60, minus the difference of these two heights, right? Okay, and I already have the heights. Okay, so I'll take the difference of these two. This is time 90, right? Okay, what is the height of this line at time 90? What is the height of this line at time 90? Okay, so this is my h1, this is my h2. Okay, so half base into h1 half h2. Okay, clear? Okay, is this the only area between these two lines? No, I have this side as well, right? Okay, I can do the same thing for this side. I can do the same thing for this side as well. This is also a big right angle triangle, then a small right angle triangle. Okay, so I will again do half base into the difference of the heights. Okay, now what is my base here? This is 90. And what about this? Okay, so base is, okay, 360 minus 9, 270. Okay, and the difference of height here? Here, what is the difference of height here? 0, right? I cannot take it here. There is no difference here, right? I'll take the difference of height where? Same point. Okay, here they are meeting again, right? So there is no difference. I can only take it here. And how much is it here? I already know it. This is 90, right? There is at point 90. Okay, so at point 90 I already know the difference. Okay, this is what they did here. The first part, half base into difference of the height. Okay, plus this part, half base into difference of the height. Okay, clear? When you add them together, you get total delay. Okay, when you add this one and this one together, you will get total delay. How much delay is it? Okay, not 400. 400,000. 400,000 something minutes. Okay, so because of this situation, we have a total delay of these many minutes. Okay, we call it vehicle minutes because this delay is calculated for the vehicles, right? It's not for the drivers and passengers. We don't know how many drivers and how many passengers, right? Okay, so this is called as vehicle minutes, but this is calculated for vehicles.
So for this triangle, it's not right.
Yeah.
Right?
I know, there is some approximation. Even the first one is not right. Even the first one is not right. Okay, but I have searched many books, this is what they are doing. Okay, they are doing some approximation. Okay, let people face more delay. What's our problem? We are doing it in the office. Huh? So, okay. So this is in minutes, and if you divide by 60, it will come into hours. Clear? This is total now. This is total. If I want average delay, then I divide by the number of vehicles, right? If I want average delay, I will divide by the number of vehicles. I have a total value. I have the total grade. If I want average grade for each student, I will divide by the number of students, right? Same thing here. I have the total delay. If I want average, I will divide by the number of vehicles. Okay? So, the delay is from which time to which time? Tell me. When does it start? Starts from here, right? And ends where? At the top, right? And what time is this? 360. So it starts at time 30 and ends at time 360. So I need to know how many vehicles are between this time, right? These are the number of vehicles which have the delay. Okay? So from where do I get these numbers? I know how many vehicles came at time 30, right? And I know how many vehicles total came at time 360. If I take the difference, I get the total number of vehicles in this time interval, right? Huh? Clear or not? Okay. So 1500 were already there, and in the end I have 2250. Oh, sorry, 26,150. I take the difference, I get the number of vehicles in this much time interval. Sure. This will come in the exam. Sure. Everybody, is this clear? Okay. So, you take the difference, you get, this is the number of vehicles which came during time 30 and time 360. Okay? These vehicles face how much delay? This much. So this divided by this will give you average delay, which is 18 minutes per week. Okay? Clear? Yes.
For the delay, we take any 2 points that have difference.
For the what?
For the delay in the first step, we take any 2 points that have.
We want the total area. So this is up to you, but you have to see the shape. You have to see the shape. At what points they are changing. Maybe it is changing for more than 1 point or 2 points. Here it was only changing at 1 point. So 2 was enough. If it is changing at more points, you have to do it accordingly. Okay? Any other question? Huh? This means you have a question? No questions. Okay. Let me summarize what we did. At time 30, demand went up. From 30 to 90, it was more than capacity. So I calculate how many vehicles will be in the queue between 30 and 90. Okay. Then at time 90, the demand went down, and I have now 10 vehicles leaving every minute. So I calculate how many minutes I need to get the whole queue gone. Okay. Which was 270. Okay. Then I came here and I calculated first of all total number of vehicles arriving, total number of vehicles leaving at every time interval. Okay, and I plotted them. After plotting them, I took the area between the two lines to calculate the delay. Okay, now the area, they took it right angle triangle. You want to make it trapezoid and rectangle, whatever. The point is, we need area between the two lines. Okay, you calculate the area, this is your total delay. Then you divide by the number of vehicles which came during this time interval, and you get average delay. Okay? Clear? Okay. This condition which we saw in the example is called as breakdown. Okay? When demand goes more than capacity, this is called as a breakdown. Okay? And the breakdown can happen because of 3 reasons. You can have a ramp coming into the highway, so there is already very high traffic on the highway, and now more people are trying to enter. It could be more than the capacity of the highway, and this could cause a breakdown. Okay? You can have 2 highways which are merging onto another highway. Okay? So some people are coming from here, some people are coming from here, and their total can be more than the capacity of the highway in which they are going. Okay, so this will cause again a breakdown. And the third one is at an intersection. So we have a section on the highway, and some people are taking right turn from here, some people are coming straight from here, some people are taking left turn. Okay, so it can happen that all these 3 make more than the capacity of the highway. Okay, and all these reasons, or for all these reasons, we can have a breakdown. Okay, clear? Okay. Now this is which case? We have two highways going on to the third one. Okay, merge point. Merge point. So here capacity 4,000, demand less than capacity. Okay, so the volume is same as demand. Okay, there are 30 people, 30 seats in the room, and 20 people are entering. So all 20 of them can enter, right? Okay, same thing here. 4,000 capacity, demand is less than capacity. So all of them will enter. Clear? Okay. Here capacity is 6,000. Capacity is 6,000. Demand is 7,400. How? How do I get this number? How do I get 7,400? Some are coming from here, some are coming from here. I add them together. Okay. So total demand is coming from there, right? Okay. But this total is now more than this. So the highway can only allow 6,000. How many are trying to enter? 7,400. So how many will enter? 6,000. Okay. The rest will be waiting outside. Like the example of the lift, right? The lift has a capacity of 10 people. 12 are trying to enter. How many will enter? 10. The remaining 2 will wait outside, right? Same thing. So the remaining are waiting outside. Clear? Any questions? Okay. I don't have much time, so I will go through it quickly because we did it in the other section. Okay. This is demand. This is the highway. It has 2 ramps for entering, 2 ramps for leaving. Demand here 2,200. How many are trying to enter from here? 800. So demand here will be how much? Let me make it a table here. Okay, section 1, 2, 3, 4, and 5. This is demand. And this is volume. Okay, section 1, demand 2,200. Section 2, how many are trying to enter? 800. 2,200 already there, right? 800 will enter. How much? 3,000. Next one, 3,000 already there, right? How many are trying to enter? 700. So total? Clear? Huh? Now, this ramp, you can see it's going out, right? This is going out, not coming in. How many are trying to get out? 500. 3,700 there and 500 will go out. Remaining? 3,200. Next one, how many are leaving? 400. 3,200 there, 400 leaving. Okay, any problem? Okay. Now look here, these are the capacities. These are the capacities. Okay. Segment 1 capacity 3,200. Volume, demand. Any problem? No problem. Number 2, capacity, demand. Any problem? Capacity is more, right? Demand is less. No problem, right? Capacity, demand. Problem or not? Problem. You call it what? Breakdown. You call it what? Breakdown. Okay. So now what will be the volume? Capacity. It cannot be more than capacity, right? It will be capacity. Okay. Now, after this, what will happen? From this ramp, how many were trying to get out? 500. 500 out of how much? 500 out of 3700. Do I have 3700 here? No. So how can 500 go out? It was 500 out of 3700, right? If I don't have 3700, how can I have 500? Okay. So now we will apply the law of equal proportion. Okay. So you see the RAM, how much they have shown? 459, right? What is 459? We were supposed to have 3700 and we have 3400, right? Okay. So I will apply the same ratio to this 500 as well. Yeah. Okay. This 500 was out of 3700. Okay. So if I don't allow 3700 to pass, I will not find 500 out of this first RAM. Okay. So how much of the 500 I can find? This much. The one which I was supposed to have and the one which I have. Okay. So this is 459. Then how did I get 2941? I know this. I know how many are going out. The remaining is 2941. This minus this. Okay. 2941 is 3200 minus 459. Clear now? Okay. Then how did I get 368? Same ratio, right? But instead of 500, now I have the RAM demand. So it will be 368. Okay. So 2941 already there minus. Okay. Clear? Okay. Some terms. I explained to you breakdown, right? The breakdown. The demand goes more than capacity. Breakdown. The section where it happens, it is called as a bottleneck. You can see on the top. The section which causes the breakdown, the section which is the reason of the breakdown, it is called as the bottleneck. The section which has demand more than capacity, it is called as what? Bottleneck. Okay. Then you see here demand and volume equal. Here demand and volume equal. Here volume and capacity are equal, right? Volume and capacity are equal. Here this is demand. This is my demand. And my capacity is how much? And what is my volume? Is it equal to demand? No. It is equal to capacity? Is it equal to capacity? Well, capacity is this. This is less than capacity, right? This is known as demand starvation. This thing which you have seen is called as demand starvation. What happened? Volume is less than capacity and it is also less than demand. Okay, this is known as demand starvation. When demand is less than volume and less than capacity, is called as demand starvation. Why did this happen? Because of a bottleneck, right? Bottleneck had a breakdown, and because of that, we had demand starvation in the other segments. Clear? Clear? Okay. Now I said bottleneck is when demand goes more than capacity, right? Demand goes more than capacity. Look at the capacity of segment 4. See now, what is the demand of segment 4? Demand is more 100. Demand is more, right? Demand is more. Did the breakdown happen in segment 4? No. It happened where? In segment 3. But if you look at the demand and the capacity, there is a potential breakdown, right? There is a potential breakdown. It did not happen because of a breakdown earlier. So this segment is known as hidden bottleneck. Supposed to be here. Do you see it? A hidden bottleneck has demand more than capacity, but it has a breakdown earlier, so it doesn't show. What the point? Okay. Segment 3 did not let segment 4 become the bottleneck. Okay. Bottleneck, where the breakdown happens, or because of which the breakdown happens. Demand starvation, when the volume is less than demand and less than capacity. It is because of a bottleneck earlier. Okay. And then we have the hidden bottleneck. Again, it is because of a bottleneck earlier. Okay. And this segment has demand more than capacity, but doesn't show. It doesn't show the breakdown. Okay. Clear? Anybody have any problem?